34, find first and last position of element in sorted array from LeetCode. Let's jump to the question. The question saying is given an integer array and it's sorted and it's in non-decreasing order, find the starting and ending position of a given value, target value. So we are looking for a target value in this array, and we should find the starting and ending indices of this target value. And if we cannot find that target value, we are going to return -1, and we should do it in logarithmic time complexity. So as you see here, we have 8 here, and it's at index 3 and index 4. So this is where we have 8. And if we don't have that value, like this example, we are looking for 6 and there's no 6 here, we're going to return -1. And for this example, we are looking for 0. We cannot find it, and we're going to return -1. Let's jump to the solution. I found this solution from discussion from this account very easy to understand and helpful, so I'm going to explain their idea for solving this problem. So we should let's jump to the code. So I'm going to divide the solution in 3 different parts. One part is when the array is empty, and one for finding the lower bound, and one while loop for finding the upper bound, and then we're going to return the result at the end. So we are going to define the lower bound and upper bound as index 0 and the length of the array -1, and we are going to define the result as -1 as a default value. So as you see in this example, the array is empty. We are looking for target value 6, and this condition applies to it. So what we are going to do, we don't need to go through any while loop or anything. We just check if the length of the array is 0. We're going to return the result, which is going to be -1. And for this example, what we're going to do, we are going to have 3 pointers, and this is how we are going to solve this in logarithmic time complexity. We are going to have a left pointer, right pointer, and mid pointer. And the way we use them is, as we know, this is a sorted array, and we are going to use this property to solve this problem. We are going to say, as long as the left pointer is smaller than right pointer, we are going to iterate over the array and see if we can find the target value. So and we go through this while loop to find the upper bound, which is here. We need to find the upper bound and replace it if we can find the target value. And we find the mid by getting the sum of the lower bound plus upper bound divided by 2, which is going to be index 3 in this case. And we check the value that we have at mid, and if the value that we have at mid is bigger than the target value, we are going to move to the right side of the array. And if it is smaller than the target value, if the target value is smaller than mid, we are going to move to the right side of the array. So how we can do that is we are going to use these 2 pointers, the left pointer and right pointer, to make these moves. So we have the mid pointer here. We check the value that we have, which is 8, and see if it is smaller than the target value. And mid is smaller than the target value, so we know that we should check the array from that midpoint to the end, because we know from midpoint to the right or to the left are smaller than the target, so there is no point in checking these values and iterating over. So we are going to move the left pointer to mid +1, which is going to be here, and we're going to find the mid, which is going to be 6 + 4 is going to be 10 divided by 2 is going to be 5. And then we check the value that we have in mid, and left pointer is smaller than right pointer still, so we continue iterating over this for loop. And we check the 13 is bigger than 11, so we know that checking the items after mid there is no point, so we are going to move the right pointer to mid, and we get the mid again, which is going to be at index 4, and we check 8 is smaller than 11, so we are going to move the left pointer to mid +1, which is going to be here. And now the left pointer is not smaller than the right pointer anymore. What we are going to do, we are going to check the conditions here, that the left value. Why we are checking left? Because we are looking for the lower bound, for the left index. For the result, we are checking for the left index. What we need to do, put here. So we are going to check the nums of left value. We check it with the target. If it is not equal to target, we are going to return the result, which was -1, -1. Let's check another example. In this example, we are looking for 8, and we are going to check, okay, the length of the array is not 0, so we keep iterating over the array. So we check the value meet is not smaller than the target. Here at this while loop that we have here, this is the first while loop that we are going to check. We check the value of the meet is not smaller than the target value 8 that we have, right? So what we're going to do, we are going to move the meet pointer to right pointer to meet, and then we're going to find the meet again. 3 divided by 2 is going to be 1, and now we check 2 is smaller than 8. Now we need to check move the left pointer to meet +1, which is going to be here. We get the meet again. It's going to be here. 5 divided by 2 is going to be 2, and now we check if 5 is smaller than target, which is smaller than the target. So we're going to move the left pointer to meet +1, which is going to be here. So now the left pointer is not smaller than the right pointer because they're both pointing at 3, and what we are going to check to see if the value that we have at the left pointer is not equal to target, which is equal to target. So we are going to update the result index 0 to the left pointer that we have, which is going to be 3 here, right? And now what we are going to do, we are going to look for the upper bound, but the trick here is like, one, we don't need to check, we don't need to move the left pointer to the beginning again, because we have found the lower bound. But we will move the right pointer to the end to see if we can find the upper bound. And this another trick that we have here, we are not going to use the meet left plus right divided by 2, because it's going to be the same. So what we're going to do, we are going to +1 that. That's the trick that we are going to use here to solve this problem. So meet is going to be, okay, 3 plus 6 is going to be 9 divided by 2 is going to be 4. 4 is going to 4 plus 1 is going to be 5. Now we are going to check the value that we have at meet, which is going to be 11. If it is bigger than the target, we are going to move the right value at meet -1, which is going to be here. 3 plus 4 is going to be 7. 7 divided by 2 is going to be 3. 3 plus 1 is going to be 4, which is going to be here. If we didn't have that +1 here, it was going to be here. So the lower bound and upper bound will be equal, and we don't want that. So now we continue and we see 8 is not bigger than target. So what we are going to do, we are going to move the left pointer to meet. So now left is not smaller than right, and we are going to use that, and we are going to update the result index 1 to the right one. Why? Because we are finding the upper bound, and it's going to be here. So it's going to be the same for these cases as well when we are finding 2 or when we are finding 11 here. Thank you.